Okay, now it's AP Calculus, Discontinuity, Part 2. Types of discontinuities. What do we mean by, first type is jump discontinuity. What do we mean by jump discontinuity? It occurs, when when the curve breaks at a particular place and starts somewhere else. So it jumped from place to place. In other words, in mathematics words, limit of a function, of a certain function, as x tends to a minus, as x approaches a from the left, does not equal limit of f of x as x approaches a from the right. Okay, we have example here. This is a function. This is a function, right? It's a part of a function drawn here. Okay, here we have a point. So at this point a, from if f of x limit approaches a from the right, we have the point here. While if we approaches a from the left, if the function came from left of a, okay, it's whole point here. This point is whole point. It's hollow point. So it's open at this point. This means at a minus from the left, okay, does not equal from a plus from the right. And this we call it a jump discontinuity in this case. Another type of discontinuity, a point discontinuity. A point discontinuity occurs, it occurs when the curve has a hole in it from a missing point because the function has a value at that point that is of the curve. In other words, limit of f of x as x approaches a does not equal f of a. So we have discontinuous, okay, at like this, okay. This is the curve comes from the left and the curve comes from the right of the point a, reaches a point which is here, it's hollow point, discontinuous, while f of a is equal to that point, it's given. So we have f of a here. So does not equal to the limit of the function from the left of a and limit of the function from the right of a. This we call it a point discontinuity. A point discontinuity. Another discontinuity we have, an essential discontinuity, occurs when the curve has a vertical asymptote. And these are two examples. If we have here a vertical asymptote in the first figure, we have here a vertical asymptote, and we can see that the function to the left of this asymptote, okay, to the left of this asymptote tends to minus infinity, and to the right it tends to plus infinity. So the limit of the function, okay, suppose this is a here, as x approaches a minus, it goes to minus infinity, and limit of the function as x approaches a plus, it goes to plus infinity. So we have discontinuity, we call it essential discontinuity. And here we have also vertical asymptote. If this is a, as x tends to a minus or as x tends to a plus, both gives me the same plus infinity. And if a tangent vertical asymptote here, it occurs, okay? Vertical asymptote, it occurs. And we don't have discontinuity, and we call it an essential discontinuity. And last type of discontinuity, we have it here in this AP calculus, a removable discontinuity. A removable discontinuity occurs when you have a rational expression with common factors in the remainder and denominator. Because these factors can cancel, the discontinuity is removable. Okay? Like we will do some examples of these later on, but here what do we have? We have a function, came from the right, from the left, sorry, of A, and from the right of A, and we have hole here inside. So we call it a removable discontinuity because we can add a point here for this function to be continuous, and we will see some examples of these later. Let's start. Example 5. Consider the following function f of x, and this is the figure of it, f of x, where f of x equal x plus 3 when x less than or equal to 2, and x squared when x greater or equal to 2. So we have it's this point here, okay? If it is less than, what do we have? If it is less than or equal, what do we have? And if it is greater than, what do we have?